This video has been sponsored by Opera. Back in 2019, I was sent some old jewelry from a viewer, and I was able to turn it into these pure 24 karat gold bars, which I thought were pretty nice. Since then, though, I've been really interested in gold in general, and a couple years ago, I stumbled onto a form of it that I'd somehow never heard of before. It was something called purple gold, and this website was selling it as jewelry, and in my opinion, it was one of the nicest forms of gold that I had ever seen. However, the color of it also kind of seemed unnatural, and at first, I honestly thought that it was probably a scam. With very little research though, I quickly found out that purple gold was actually real, and according to Wikipedia, it was an alloy of gold and aluminum. Now, I'm not someone who's normally into jewelry, but for some reason, the moment that I saw that it was real, I really wanted to buy some. More specifically though, I really wanted a ring that was made entirely out of purple gold. However, long story short, that website didn't sell one, and as far as I could tell, there wasn't a single company or person in the world who sold a pure purple gold ring. At first, I thought this was kind of odd, but apparently this was just because purple gold was a huge pain to make and to work with in general. It also turned out that Li Hua, the owner of that website, was one of the only companies that even made purple gold jewelry. With all that being said though, I still really wanted a pure purple gold ring, and now, knowing that it was actually impossible to buy, I kind of wanted it even more. At the same time, I also felt that it had to be possible to make an entire ring out of it, and I started thinking that this was something that I might just be able to make myself. I mean, I had absolutely zero experience with purple gold, and I had never made a ring out of anything before, but for some reason, I really felt that I could do it, and I decided to just go for it. But anyway, to get started, the first thing that I had to do was figure out how to even make the purple gold, and with a quick Google search, I was able to find a lot of videos and articles talking about it. However, none of them gave any real information on how to make anything remotely decent. With a bit more searching though, I was eventually able to find this patent, which turned out to be extremely useful. This is because it not only gave a lot of good info about purple gold in general, it also explained how to potentially fix one of the biggest problems with it, which was how fragile it was. It said that normally, with the typical mixture of about 78.5% gold and 21.5% aluminum, it was as brittle as glass or porcelain, and that it was way too fragile to make any jewelry with it. However, it claimed that by altering its composition just slightly, or by adding some other metals to it, like palladium or nickel, it was possible to make purple gold that was significantly stronger. It also provided a bunch of example recipes, and the one that caught my eye was this one, which appeared to be the simplest. It didn't require any other metals besides gold and aluminum, and the only difference was that the gold content was slightly increased to 81%, which would make it about 19 karat gold, and this was what I decided to go with. The only tricky part was that besides the ingredients, it really didn't tell me anything else, and there was pretty much no information on how to actually make the purple gold. So unfortunately, this meant that I was going to have to figure out everything myself, and considering that it was supposed to be really hard to work with, I was honestly kind of worried. What made me feel slightly better though was that at the last second, I found out that all of the purple gold that's sold by Li Hua is actually based on this patent. So even though it didn't give any real instructions, I at least knew that the recipe itself should have been trustworthy, and I decided to just go for it. With that being said, I could now actually get started, and the first and most important thing that I needed was some gold, which unfortunately isn't exactly cheap. So I initially planned on buying as little as possible, and I figured that something like 20 grams would probably be more than enough. At the last minute though, I convinced myself that it was a good idea to get a bit more, just in case I needed it, and long story short, I ended up with this 100-gram bar. In total, this cost me about $5,700 US, or about $7,800 Canadian, and this immediately put me over the budget that I originally had for this project, and it was probably way more than I needed, but oh well. Either way, I now had this beautiful and shiny bar of gold, and just looking at it and holding it in my hand was oddly satisfying. The only sad part was that it was kind of useless to me as one big bar, and unfortunately, the first thing that I had to do with it was destroy it. More specifically, I was going to have to break it apart into a bunch of smaller pieces because I had to be able to measure out very specific and accurate amounts of it. To do this, the most obvious way would have been to tear it apart manually using something like a chisel and a hammer, but that would have been an insane amount of work with most likely mediocre results. Instead, I felt that it was a much better idea to do it chemically, so I just carefully placed it in a beaker and I poured in a bunch of concentrated hydrochloric acid. I then turned on the heating, and over the next few minutes, it slowly warmed up, and it eventually started boiling. Then, when I felt that I was ready, I shot in some concentrated nitric acid. Almost immediately, there was a lot more bubbling, and the solution started changing color. This is because the nitric acid was reacting with the hydrochloric acid, and it was forming nitrosyl chloride and chlorine gas, both of which are yellow. More importantly, though, unlike the hydrochloric acid alone, this new acid mixture, commonly known as aqua regia, was able to attack the gold bar. It wasn't super fast, but it was slowly shredding it apart, and it was turning it into something called chloroauric acid, which was then getting dissolved away. So, what I was doing here was basically breaking it apart at the atomic level, which was way better than I could ever do manually, and on top of that, it was just a lot easier. All I had to do was occasionally add small amounts of nitric acid, and over the next few hours, it very slowly disappeared. Eventually, all that was left was just a thin sheet of gold, and with just a little bit more acid, I was able to completely get rid of it. There was now absolutely no trace of the original bar, and all 100 grams of the gold was dissolved as the chloroauric acid. I then let it cool down to room temperature, and what I had to do next was turn all of this chloroauric acid back into metallic gold. At first, it might not make much sense why I just dissolved it all, only to immediately bring it back, but it'll all make sense in a few minutes. With that being said, I then just grabbed the beaker and started walking over to my other fume hood.
Oh no.
Okay, that was actually just a beaker full of water and food coloring, and what I really did was pour it all into a bunch of extra water. I also washed the beaker a few times with some more water to make sure that there was absolutely no gold left behind. Then after that, I stirred it around to make sure that it was all fully mixed, and when I felt that I was ready, I dumped in a concentrated solution of potassium metabisulfite. This caused the entire thing to quickly turn brown and to heat up a lot, and I was really happy to see this. This is because it meant that the potassium metabisulfite was working and that it was reducing all of the gold in the chloroauric acid back to its metallic form. The very important part, though, was that it wasn't all just coming back as a large chunk or something, and it was instead crashing out as a superfine powder. So, by just dissolving the bar and bringing it back, I had effectively pulverized it to a dust, and again, this was way better and easier than anything I ever could have done manually. Over the next 30 minutes, pretty much all of it sank to the bottom, but there was still a small amount of it floating around. So, I decided to leave it overnight, and when I came back to it the next day, it was completely clear. I was now able to get rid of all the water, and I just quickly poured it out into another container. I was also very careful to not lose any of the gold, and when it eventually looked like there was almost no water left, I transferred it all to a small beaker. I then poured in some boiling distilled water, and I turned on the hot plate, and I let it sit there for several minutes. I was doing this to get rid of any residual potassium metabisulfite and other side products, and after that, I did it a few times with hot hydrochloric acid. This would help get rid of any trace impurities of other metals that might be there, and when I felt that it looked good, I washed it a few more times with hot water. What I had now should have been some super nice and clean gold, and all I had to do next was dry it, so I cranked up the heating on the hot plate, and I waited for all the water to disappear. This ended up taking over an hour, which was way longer than I expected, but when it was eventually done, I had some nice and crispy powdered gold. When I weighed it, it was also 99.99 grams, and this meant that I had only lost 0.01 grams in this entire process. However, considering that the original bar was only 99.99% pure, it was very possible that this small amount was actually just some impurity, and that what I had now was more pure than it was before. But anyway, at this point, all of the gold was ready to go, and the only other thing that I needed was some aluminum, and I bought this bag of it from eBay. It was supposed to be 99.995% pure, and it was the absolute highest purity that I was able to find. It also came as a bunch of small pellets, which I felt would make it easy to measure out, and now it was finally time to try and make some purple gold. So I carefully measured out 4.95 grams of the gold, which was really easy to do in its powder form, and I added it to a small crucible. Normally, I also would have added something called borax, which would both help the gold melt and prevent it from sticking to the dish, but I unfortunately couldn't do that here because it would react with the aluminum. Either way, I then just started blasting it with a blowtorch, and very quickly the top of it turned red hot, and I could slowly see some of it starting to melt. As I kept heating it, it was also slowly shrinking, and about 30 seconds later, I was left with two separate blobs, which eventually combined to form a nice little bead. I then kept blasting it just to get it as hot as possible, and when it was red hot, I dumped in exactly 1.61 grams of the aluminum metal. The ones that were touching the gold almost immediately melted and combined with it, but it looked like the others needed a bit more convincing. However, even after making them red hot, they still weren't melting, and this was because the thin oxide layer that naturally forms around aluminum was holding in the liquid metal. So to actually get it to mix, I was going to have to poke at it a bit, and I was happy to see that it all easily combined together. What I was more happy to see, though, was that below all of the crusty oxides on the top, it looked like there was a nice and free-flowing liquid. I was also kind of surprised to see this, because there were at least a few comments that I read online which said that doing this in the presence of air would turn the entire thing into a horrible oxidized mess. However, it wasn't nearly as reactive as I initially thought, and it definitely seemed like it could be possible to pour this into a mold or something. With that being said, I now theoretically had a mixture of 81% gold and 19% aluminum, except it wasn't even remotely purple, and this was because it was still way too hot. It was also still a liquid, and to get it to turn purple, I was gonna have to let it cool down. As this happened, it was supposed to slowly crystallize as an alloy, where most of it had the chemical formula AuAl2, which is the form that has a really nice purple color. According to the patent, though, by skewing the gold content slightly higher than the typical 78.5%, it would push a bunch of it towards a gamma-phase gold-aluminum structure. I honestly still don't entirely know what that means, and I've had a very hard time finding any good info about it, but the important part was that it was supposed to make the alloy a lot stronger. When it did eventually get to room temperature, though, it sadly still wasn't purple, because it was covered in a bunch of blue oxidized junk. If there were actually any purple gold, it was all hidden inside, and to see if it were there, I was first going to have to get it out of the crucible. So I just carefully poked at it with a metal spatula, and even without any borax, it was surprisingly easy to remove. What I had now was a super crusty and ugly piece of metal, and to see if I had actually made any purple gold, all I had to do was break it open. I also figured that this would be pretty easy considering how weak and brittle even this stronger stuff was supposed to be, so I just tried snapping it in half. However, it turned out to be a lot tougher than I expected, and it really didn't feel like I was even close to breaking it. So instead, I decided to just quickly kill it with a hammer, and I kind of assumed that it would easily shatter. But again, that apparently wasn't the case. I mean, I didn't exactly hit it super hard, but still, it definitely didn't seem like it was as brittle as glass or porcelain, and all of that gamma phase stuff appeared to be working. But anyway, I then just kept hitting it, each time doing it a bit harder, and when it did eventually break, I was really happy with what I saw. Inside of it was a bunch of beautiful purple gold, and the color of it almost seemed unnatural. What I thought was kind of odd, though, was that it wasn't quite the purple that I was expecting, and it seemed like it was a lot pinker than the jewelry I'd seen online. This made me think that maybe I'd chosen a bad recipe or something, but when I checked the patent, it actually said that it was supposed to be a pinkish purple. It also said the same thing for all of the other recipes, and again, considering that this was the patent that the Liwa stuff was based on, I trusted that it was probably good. I also started thinking that maybe the darker color only came out later on in the process, or when it was being polished or something, and I decided to just keep going. So now, assuming that this recipe was good, what I had to do next was somehow figure out how to go from just making a bunch of crusty crap to a nice and shiny ring. This was going to be a lot of work, though, and just thinking about all of the different things that I was going to have to test kind of overwhelmed me, and this made me feel that the only way to move forward was to just take the process step by step. This way, I wouldn't break my brain, and I would only have to focus on one major problem at a time, and right now, I felt that the biggest issue was the oxides. This is because they were clearly making everything a huge mess, and if I even wanted a remote chance of making anything nice, I was definitely going to have to get rid of them. To do this, there was also only one real way, and I was going to have to somehow stop the aluminum from reacting with oxygen in the air. So I went online looking for some ideas, and after searching for a long time, I was only able to find two decent suggestions. The first was to buy a super expensive and specialized inert atmosphere casting machine, and the second one was to basically custom build something that was equivalent. However, I really didn't feel like it had to be that complicated or expensive, and after thinking about it for a while, I came up with an idea that I thought was relatively simple. I figured that all I had to do was use this small tabletop furnace that I already owned, and to load in one of my smallest crucibles. Then after that, I just lowered in some stainless steel tubing that I'd gotten for free, and I'd quickly bent it to fit around the furnace. What was important, though, was that at the other end of this tubing, it was connected to a tank filled with inert argon gas that I'd gotten from a local welding shop, and that was basically it. What I had now was just a regular furnace with the ability to shoot some argon into it, and I really felt that it was going to work. There was only one way to find out, though, so I quickly added the gold, started a steady flow of argon, and I set the furnace to 2200 Fahrenheit, which is about 1100 Celsius. Over the next 15 minutes, it then slowly heated up, and the gold powder slowly shrank, except it was looking like it was having some trouble melting with the top open, so I covered it with some KO wool. After that, it only took a few minutes to have a nice little blob of gold at the bottom, and now I could add the aluminum. This time, though, I decided to use some much larger pieces of it, which weren't quite as pure, but I was hoping that they would liquefy a lot more easily than the smaller ones. To load it in, I just carefully dropped in the first piece, and I was very happy to see that it all quickly combined with the gold. I then added the rest of the aluminum, which also quickly got sucked up, and at this point, it was already looking way better than the first attempt. What I was especially excited about was that it looked like there were barely any oxides, and this meant that the argon was doing a decent job. This was also really impressive considering that the aluminum was red hot, and that it was way more reactive than normal liquid aluminum. But anyway, what I had now was some nice and relatively oxide-free purple gold, and what I had to do next was try and pour it. In theory, it probably would have been a good idea to protect it from air while I did that as well, and I did consider putting together some sort of specialized setup. However, instead, I decided to go with the very sophisticated method of just going as fast as possible. So I just quickly got rid of the argon line, pulled the crucible out of the furnace, and tried pouring it out onto a preheated graphite mold. As I did this, I was really hoping to see a nice stream of red-hot metal, but nothing was coming out, and it didn't even work when I tilted it completely upside down. At first, I was kind of confused, but then I realized that all of the purple gold had just frozen in the crucible. Apparently, just a few seconds was enough for it to cool down below its melting point, and I was clearly going to have to get it as hot as possible. So I just put it back in the furnace, dropped in the argon line, and covered the top, and I left it there until the entire thing was bright red. I then again attempted to go as fast as possible, and it was still a bit stubborn, but I was actually able to pour it out. The only sad part was that it was a complete piece of trash, and having to remelt it had apparently caused it to get really oxidized. This told me that I only had one real chance to pour it out, which wasn't ideal, but at least now, I knew exactly what to do. So I quickly whipped up a new batch of the purple gold, and this time when I poured it out, I was really happy with what I saw. I then let it cool down to room temperature, and when I took a closer look at it, it was definitely the best result that I had so far. I mean, it still wasn't perfect, but it looked way cleaner, and it wasn't anything like the crusty mess that I had before. The only thing that I thought was odd was that it was silver, and I had assumed that without a lot of the oxides, that it would have been significantly more purple. At the same time, though, I figured that maybe it was just a bit of aluminum or something that was on the surface, and that it would be really easy to get rid of. So I decided to try sanding it a bit, and I was assuming that when I flipped it over, I would see that really nice pinkish purple color, except it was still just silver. I then tried sanding it even more, thinking that maybe I just hadn't taken enough away, but it didn't seem to make a difference. When I saw this, I was honestly kind of confused, and the only explanation that I could think of was that I had somehow failed to make the purple gold. So to check this, I was going to have to break it open, and this time, I was even more surprised by how strong it was. I was hitting it way harder than before, and it didn't seem to do anything, and eventually, it ended up making a huge dent in my wooden table. After hitting it 7 times, though, I was finally able to crack a small piece off of it, and I was kind of upset by what I saw. This is because inside of it, it was definitely colored, and it made no sense why sanding it wasn't working. What I thought was even more upsetting, though, was that it was only barely pink, and it wasn't nearly as vibrant as the first attempt. This also really didn't make any sense to me, because I'd basically done the exact same thing as before, except without any air present, and it really shouldn't have had any effect on the color. However, I was going to have to be absolutely sure that this wasn't an issue with the new setup, or with the different aluminum, and to test this, I just quickly did the exact same thing, and I made a fresh piece of it, and I waited for it to cool down. I then got my hammer, and this time I protected my table with a steel plate, and after one good hit, I was really happy with what I saw. It was actually purple, which told me that my setup and my aluminum were probably fine, and I still have no idea what went wrong with the first one. Either way, I then took one of these pieces, and I assumed that with the much stronger color, it would actually sand properly, but that apparently wasn't the case. Like before, no matter how much I sanded it, it never turned purple, and I just couldn't understand why. What was even worse, though, was that after this, I tried just sanding the purple part itself, mostly out of desperation, and I was devastated when I saw that it turned silver. I had no idea how this was even possible, but it was a horrible thing to see, because if sanding it or grinding it wasn't an option, it would be extremely hard to make anything nice out of it. As a completely last-ditch effort to fix this problem, I decided to drop this little piece of it into a beaker and to add some hydrochloric acid. I thought that maybe just a very thin layer of aluminum was blocking the purple gold or something, and I was hoping that the acid would get rid of it. However, as the aluminum disappeared, it just slowly went back to being pure gold, which I actually thought was pretty interesting, but it didn't help me at all. At this point, I was really lost as to why this was happening, and I had almost no idea how to fix it, and I ended up spending the next few days trying a bunch of other random stuff. I then spent another few days reading everything that I could find online, and after finding absolutely nothing useful, I honestly kind of felt like giving up. Before doing that though, I decided to look at the patent one last time, and this turned out to be a really good idea because I saw something that I'd somehow never noticed before. It was also almost just said in passing, but it was here where it was mentioning the purple color, and the key words were, "at least on annealing, at 600 C. This didn't directly address the problem that I was having, but it implied that there was a way to enhance or recover the color, and I figured that this was my only chance. So I just quickly preheated an unused crucible to 600 C, and for this attempt, I also made this fresh new piece that I had sanded down nice and flat. Just like all the other times, this made it completely silver, and it kind of just looked like a generic piece of metal, and I had a hard time believing that this could actually turn purple. There was only one way to find out though, so I dropped it into the crucible, and then based on absolutely nothing, I decided to leave it for about 30 minutes. When I came back to it, I was honestly feeling pretty hopeful, and I was really curious to see how it was doing. So to get a closer look at it, I just carefully pulled out the crucible, and I dumped it onto some insulation, and I was genuinely shocked by what I saw. Almost like magic, it had actually somehow turned purple, and the moment that I saw this, I was really relieved. This is because it was very obvious that the heat treatment had worked, and the project was thankfully no longer at a complete dead end. What I thought was really interesting, though, was that as it continued cooling down, the color of it slowly changed, and it was gradually shifting more towards that pinkish purple. However, it didn't seem to get quite as pink as I saw with the first attempt, and when I took a closer look at it, it appeared to be a darker purple. I mean, it still definitely wasn't as purple as the stuff that I saw online, but this at least showed me that even with the same recipe, the color could actually be pretty different. This also made me think that maybe by annealing it for longer, or just in a different way, it might have been possible to make it even more purple. With all that being said though, right now what I had was still kind of a piece of crap, and I felt that the most important thing to do next was to see if it was even possible to make something nice. More specifically, I had to see if I could actually mold it into a specific shape and then clean it up, and I was really tempted to just immediately try and make a ring. However, I knew that starting with something complicated like a ring would be a horrible idea, and it would introduce a whole bunch of new issues, so instead, I decided to just make a simple little bar. In particular though, I really wanted to make one that looked exactly like a typical gold bar, except that it was purple, and I went ahead and melted a bunch more metal. After that, I went and got one of my small bar molds, and this time, I was gonna blast it until it was red hot. I was really hoping that this would prevent the metal from freezing and help it fill the mold better, and when I felt that I was ready, I carefully poured it in. I was a bit concerned that I was going to miss or something, but it all turned out fine, and I was really happy to see that it easily filled the entire mold. I then let it all slowly cool down, and when it was eventually around room temperature, I had to get it out of the mold, and I was a bit worried that it might be stuck. However, that clearly wasn't the case, and it just easily fell out, and this made it pretty clear to me that there was no issue with molding it. There was of course still one problem though, and that was how ugly it was, and what I had to do next was see if I could actually turn it into something nice. To do this, I decided to just sand it by hand, which wasn't exactly ideal, but I didn't want to lose any of the precious gold dust. Unsurprisingly though, this turned out to be super tedious and difficult, and it ended up taking 10 hours to get it into a shape that I liked. I then polished it by moving up to finer and finer sandpapers, and when I eventually felt that it looked good, I annealed it, and this was the final result. It was pretty much exactly what I was hoping for, and it was just like a normal gold bar, except it was pinkish purple, and I was really happy with how it turned out. The only thing that I thought was odd was that it didn't seem nearly as purple as my other piece, and this one kind of looked like it was a light pink. However, after a bunch of testing, I found that this was mostly just because it was way shinier, which made it appear a lot brighter, and I'll talk more about this later on. With all that being said, though, being able to make this fully proved to me that it was definitely possible to cast and clean up the purple gold, and at this point, I was feeling pretty excited. However, my mood completely changed when I decided to take a much closer look at it, and I was kind of horrified by what I saw. It was apparently riddled with a bunch of small cracks, and I have no idea how I didn't see this at all up until now, and I think I was just blinded by all of the excitement. What made things even worse was that it also looked like the color wasn't very uniform, and there were a lot of spots that appeared to be completely colorless, almost like the metals didn't mix properly. In my opinion, though, that would be a relatively easy fix, and I just had to mix things better, and the much bigger problem was all of the cracks. This is especially because once I noticed them, I couldn't just unsee them, and I couldn't help but think that they were super ugly. What made it even more horrible was that it was throughout the entire thing, which meant that I couldn't just sand it away, and when I looked back at some other random pieces that I made, I noticed that it was there too. At first, I tried to convince myself that maybe that was just how purple gold was, and to prove this, I ended up buying a small pendant from Li Hua. The moment that I opened the box, though, I immediately realized that I was just in denial. This because the surface of it looked almost perfect, and I wasn't able to see any of those gross cracks in it. It was only when I really zoomed in that I could actually see some small surface defects, and there were definitely at least a few small holes. I could also vaguely see that, like mine, the color wasn't perfectly uniform either, but overall, it was clearly way better than what I made. As a quick side note, it also seemed to be significantly more purple than my pinkish bar, but again, this turned out to be mostly just a lighting thing, and I promise that I'll talk about this more later on. But anyway, at this point, it was pretty obvious that these holes weren't meant to be there, and the very unfortunate part was that I still had no idea what I was doing wrong. All I knew was that I hated how ugly it was, and that this was unfortunately something else that I was going to have to fix, and this project really just felt like a never-ending sequence of problems. With that being said, just like before, I ended up trying a bunch of random things, and when they all inevitably failed, I desperately looked at the patent, and I tried searching online. However, unlike last time, I wasn't able to find even a vague reference of this happening with purple gold. What I did find, though, were a lot of sources that mentioned a very similar problem that commonly happened with pure aluminum. I also found a really useful report that talked about this issue in detail, and they provided a photo of what it could make the aluminum look like. All of the dark spots were small holes, just like what I was seeing with the purple gold, and apparently, this was mostly just caused by moisture in the air. This is because when aluminum is molten, it's able to react with the moisture, which then causes it to form some of those crusty oxides like we saw before, as well as some hydrogen gas. I always kind of assumed that all of this hydrogen then kind of just floated away, but apparently, a lot of it actually gets dissolved into the molten aluminum. Then, as the aluminum cools, the solubility of the hydrogen slowly decreases, and right around the time that the aluminum is solidifying, it all gets kicked out as a bunch of bubbles. What I thought was interesting, though, was that they also provided this photo, which is what it looks like if all of the hydrogen's removed before it solidifies. There's a pretty obvious difference, and all of those cavities are completely gone, and now, it's just a nice and smooth piece of aluminum. After seeing this, I felt that it was pretty clear that this was almost the exact same issue that I was having, and this seemed to be confirmed when I looked back at some of my footage. More specifically, I looked back to when the bar was solidifying, and I was able to see what looked like bubbles popping on the surface. When I saw this, I felt that it was pretty clear that this was all just hydrogen gas getting kicked out as it solidified. The only thing that I thought was weird was that I was already using argon to block out all of the air, and therefore the moisture, and I wasn't entirely sure where this hydrogen was coming from. I mean, it was possible that it was from the short period of time that it sat there in open air before solidifying, but I really didn't feel like that was the case. Either way though, if I wanted to make something that wasn't hideous, I was going to have to somehow get all of the hydrogen out of the aluminum, and there were apparently many different ways to do this. So I decided to just try everything that I thought might work, and one method that I thought was really promising was to just include a bunch of table salt. However, again, most of the things that I tried totally failed, and after a week of frustration, I felt that I was left with only one real option. For this one, I was going to have to try and bubble some argon gas through the molten purple gold, instead of just using it to protect it from air. This was actually something that I'd been kind of avoiding, because even though it sounded relatively simple, it was kind of tricky, and I wasn't going to be able to just lower in my stainless steel tubing. This is because at 1200 C, the aluminum was way too angry, and it would just dissolve it, and I saw this happen firsthand when it dissolved one of my steel spatulas. So, I was gonna have to swap out my tubing for one with a different material, and unfortunately, there weren't many other options. I couldn't just use other metals because they would also probably get dissolved, I couldn't use glass because it would melt, and I couldn't use graphite because, as far as I can tell, small graphite tubes don't exist. After thinking about it for a while though, I started wondering if something like fused quartz might work, and I remembered that I actually had a bunch of small tubes that I'd gotten for free. Just by looking at them, they appeared to be pretty much the same as normal glass, except unlike normal glass, they were made with nearly 100% silicon dioxide. This would make them significantly more resistant to high temperatures, and there should be almost no risk of it melting or cracking, and I really didn't see why it wouldn't work. I also had a lot of faith in fused quartz after I'd used some to burn diamonds, and it had survived being red hot under a flow of pure oxygen. So I decided to give it a chance, and I was really excited to get started, but then I realized that I actually had no gold left. This is because in all of my random attempts, I had apparently used all 99.99 grams of it, and it was now just a bunch of random trash. This was kind of a huge pain, but I didn't really have a choice, and I just quickly redissolved it all in a bunch of acid, and I processed it in the same way as the original gold bar. Then after a couple days of work, I had some nice and crispy gold powder, except when I weighed it, it was only 95 grams. This meant that I'd somehow lost about 5 grams of gold along the way, and this made no sense to me because I'd been extremely careful, and I thought that I'd collected absolutely everything. Either way, I could now finally test out my new method, so I went back to my furnace, and I poured in all 95 grams of the gold that I had just purified. This is because I didn't think that it could be done on a very small scale, and if I wanted to actually be able to bubble gas through it, I felt that I was going to need as much molten metal as possible. With all of the gold melted, I then carefully lowered in the quartz tube, and with it in place, I slowly opened the argon. Then on top of this, I dumped in the aluminum, which all quickly melted, and this time, I stirred it with a graphite rod. This was also what I should have been using from the beginning, because unlike my spatula, it wouldn't just dissolve, and when I eventually felt that it looked good, I lowered in the quartz tube, and I slowly increased the gas flow. My goal was to get it to bubble as much as possible without splashing too much, and the idea here was that the argon would carry the hydrogen out of the metal. To a certain degree, this would also help mix the gold and aluminum, and when I felt that it was going at a steady rate, I covered it with some insulation. I then had to leave it like this for a while to make sure that I got out as much of the hydrogen as possible, and based on what I read online, about 20 minutes seemed decent. So I basically just had to wait, and in the meantime, I went and got my mold, which was again, just a simple bar mold. This is because I had to make something that I could compare to the last one and to see if this process had actually made a difference. But anyway, at this point, it had been about 20 minutes, so I started blasting the mold with the torch. Then, when I eventually felt that it looked nice and hot, I quickly took apart the whole degassing setup, and going as fast as I could, I poured it all into the mold. After that, I waited for it to cool down, and when it got to around room temperature, I popped it out of the mold, and I started cleaning it up. Almost immediately, it was already pretty clear that there was a major improvement, and even after very little sanding, it looked like most of the cracks were gone. I would only really be able to know for sure once it was all nice and shiny though, so I just kept on going, and many horribly painful hours later, I annealed it, and this was what I eventually had. Without even comparing it to the other bar, this one was clearly way better, and what I was extremely happy to see was that it didn't seem to be riddled with a bunch of small holes. To actually know how much better it was, though, I was going to have to pull up a photo of the old one, and the moment that I saw it, the difference genuinely surprised me. It was actually somehow even uglier than I remembered, and it was pretty undeniable that the degassing step had made a significant difference. I mean, if I really zoomed in, I could clearly see some very small holes, and it definitely wasn't perfect, but overall, I still thought that it was really nice, and I was very happy with how it turned out. The only thing that was still kind of off was the color, and just like the other bar, it was definitely more on the pink side. However, as I mentioned a couple times earlier, it turned out that this was all just an annoying lighting issue. This was actually something that really messed with my head for a while, and it's honestly sad how long I spent staring at little pieces of metal and trying to compare their colors. What really settled things for me, though, was getting that pendant from Li Hua, which allowed me to compare my stuff to some professionally produced purple gold. I also started using a polarizer for my camera, which would let me remove some of the reflections, and suddenly, it was very clear that they were the same color. To me, this really showed that it was all just lighting, and I think that my bar is just a lot shinier or something, which makes it generally appear brighter. Color aside though, at this point, I finally had what I felt was a decent way to make the purple gold, and after months of going in circles, this was a huge relief. However, I of course wasn't quite done yet, and the last thing that I still had to do was make my ring, which was the entire reason why I started this project. The only concerning part was that I still wasn't entirely sure how to do this, and I was kind of worried that I'd end up in another horrible pit of trial and error. To try and avoid this though, I decided to go with the simplest method that I could think of, and the first thing that I did was buy a ring sizer from Amazon. I then tested a bunch of them to see which one fit my finger the best, and this was extremely important. This is because, as we saw before, the purple gold was completely non-malleable, and this meant that any cast that I made had to be almost perfectly pre-sized. With that being said, when I eventually found one that I thought fit, I was able to make a super basic 3D design, and now I just had to turn this into a mold. With normal gold, there are a few common ways to do this, like with lost PLA casting, but I was worried that all of them would end up having issues with the purple gold. So instead, I decided the best idea was to just do it in a graphite mold, which I was now very familiar with, and I knew would probably work. The only tricky part was that I couldn't just buy a mold, and for it to perfectly fit my finger, it was gonna have to be custom made. In theory, I probably could have found someone online to do this for me, but instead I used this as an excuse to buy a CNC machine and to learn how to carve out my own graphite molds. This actually ended up being a lot of fun, even though it was sometimes a bit frustrating, and I can now make pretty much any graphite mold that I want. With that being said, for this project, all I had to do was make this super simple one, and with it now ready, I was finally able to try and make the ring. So again, I just quickly repurified all of the gold that wasn't used to make my big bar, and I remelted half of it in the furnace. I did this so I'd be able to get at least 2 attempts, and I was just hoping that 30 grams of gold and about 7 grams of aluminum would give enough volume for the degassing. I then let it sit there, and after about 15 minutes, I started blasting the mold with a torch, and I was eventually ready to try and pour it. I was honestly really concerned that I would either completely miss or that the metal wouldn't flow through the entire thing, but it turned out to be totally fine. All I had to do now was wait for it to cool down, except this part I was actually more concerned about because I knew that this was going to cause it to shrink. This was also a huge issue because this meant that the inner side of the ring would start contracting while the outer side of it would stretch, and since the purple gold had no real malleability or ductility, this would almost definitely cause it to break. To try and avoid this, I'd purposely angled the inner edges of the mold, hoping that as it contracted, it might pop itself out without cracking. At the same time, I genuinely believed that there was a narrow window of time where it was possible to manually remove it, and I just kept trying to pry it out. However, I apparently wasn't skilled enough, and it ended up just cracking itself in half. It just snapped. This was also really sad because the ring had actually molded super well, and now, unless I want to spend days repurifying everything again, I only had one last chance. So I just anxiously whipped together another batch, heated the mold red hot, and carefully poured everything in. This time though, there somehow wasn't enough metal to fill the entire mold, and at first I was sad about this, but it actually turned out to be a good thing. This is because it prevented the ring from fully connecting, so as it contracted, it didn't just squeeze down on the middle part and snap itself, and I was actually able to get it out of the mold. Huh. What I had now wasn't exactly what I was expecting, and it kind of looked like a failed attempt, but at the same time, I felt that this different shape was kind of cool, and I decided to just go with it. I then spent the next couple of days sanding and grinding it, and this time I also used a Dremel, which made things a lot easier. The part that I actually had the most trouble with was just coming up with a design that I liked, and almost the entire time, I was really worried that it would turn out absolutely hideous. Eventually, though, I was able to make something that I felt I was happy with, so I polished it up as best I could and then annealed it, and this was the final result. It was honestly way nicer than I ever imagined it would be, and I kind of found it hard to believe that I had actually done it. I finally had my ring that was made entirely out of purple gold, and it was probably one of the only ones in existence, and after months of work, I think it was all worth it. What was also nice was that it wasn't nearly as fragile as I thought it would be, and even though I'm not going to test it, I don't think it would break if I dropped it. I also don't think that it would be a problem to casually wear it, as long as I'm careful, and I would probably just have to avoid accidentally slamming it into things. With all that being said though, when I first started this project, I was honestly really concerned that it would just be a total failure, especially because of all of the things that I had read online. However, it turned out that purple gold wasn't nearly as bad to work with as I thought, and with just a relatively simple setup, I definitely think that it's possible to make some nice jewelry. I also think that there's still a lot of room for improvement on the method that I used, and I already have a few ideas that I want to test out. For example, something that I really want to try is just using higher purity argon, which has less moisture in it, and I want to try swapping my quartz tubes for something like alumina. I'm also kind of tempted to completely switch to a different degassing method like ultrasonic, and most importantly, I think there are definitely some better ways to cast and mold it. For now though, I think I'm kind of tired of melting, casting, and grinding purple gold, And instead, I'm going to work on some more tasty projects, like turning air into alcohol. Okay, so in the end, this was probably the most tedious and frustrating project that I ever worked on, and what made it even worse was that I somehow kept on losing gold. I honestly still have no idea where it went, because I was really careful with everything, and I'm kind of convinced that it just got evaporated or something with the aluminum. Either way, though, I'm really happy that it's all finally done, and I want to give a big thanks to my patrons for making projects like this possible, and to Opera for sponsoring this video. I've been using Opera on desktop for a while now, and in my opinion, it's still the best browser that I've ever used. Not only is it really fast and intuitive, and loaded with a bunch of extra features, it also just got an update to its Lucid mode, which I think is pretty cool. This is because with just a click of a button, it's possible to immediately enhance any video, and now with this update, it's also possible to manually adjust the sharpness, and there's also a button to easily see a before and after. Besides Lucid mode though, another feature that I like is this sidebar, which I think is really useful. This is because it lets me easily access all of the social media that I often use, like Messenger, WhatsApp, Instagram, and TikTok, and it even has an integrated music app where I can listen to things like Spotify and Apple Music. On top of all of this, they even have a built-in VPN service and an ad blocker, as well as some integrated AI tools. In particular, they have Aria, which is Opera's native and completely free AI service, and it's similar to ChatGPT, except with even more features. It's also totally optional whether or not you want to use Aria, and it would only be activated if you choose to opt in. Besides all of these tools though, what I also really like is their Tab Island feature, which really helps me get all of my tabs under control, and this is especially useful when I'm doing research for a project. With that being said though, I've been having a really nice time just using Opera in general, and I still think that it's worth giving it a try for just the sidebar alone. It's also, of course, completely free to use, and you can download it right now by clicking the link in the description. That's it. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.